Okay, right now we're on the page relation and dependency, which is the one that looks like this right here. You'll notice right below the picture it says that a mathematical relation expresses a dependent relation where one quantity depends in a systematic way on another quantity. So, in some cases, there is a cause and effect relation where the cause is the independent variable and the effect is the dependent variable. And I'm going to give you a couple of examples so you can see what exactly they're talking about. The first example says that Lake Travis will rise 2 feet if it rains 15 inches. So notice here, it says Lake Travis is going to rise 2 feet, but only if it rains 15 inches. Okay? So, we're going to talk about what the dependent and the independent is, but notice we've got a cause and effect here. The effect we have is that Lake Travis is going to rise 2 feet. And what causes Lake Travis to rise 2 feet? The fact that it rains 15 inches. So that's what they're talking about when they say cause and effect. The cause is rising 2 feet, or that's the effect. The cause of that was the 15 inches of rain. All right, let me show you a couple more here. In other cases, there is not a cause and effect relation, but rather, or there could still be an independent and dependent relation. In this type of relation, either can be the independent variable, which then forces the other to be the dependent variable. And here's a good example of that. Number 2. It says that Henry has an arm span of 64 inches. In other words, if we put our arms out from one fingertip to the other, that's 64 inches. His height is 66 inches. Okay? So notice these can be interchangeable. The reason he has a arm span of 64 inches is because he's a tall person, or 66 inches tall. Or we can say it the other way around. The reason that he has a 64-inch span reach is because he's 66 inches tall. Or we can do it the other way around. Okay, and we'll talk more about that here in a little while. So this right here can go either way. The last one down at the bottom, number 3 here, says we have the example y equals 2x plus 1, and it's a function and expresses a dependency relation. So you'll notice that we have an x and a y, or an input and an output. If I replace x with a, let's say, a 0, write that down for me on your paper. If I were to plug in a 0 for the x, if I input 0 for x, I get a certain output. I get a certain y value. The question is, what y value would I get if I replace x with a 0? Can anybody tell me what I would get? What is 2 times 0? 0. And 0 plus 1 is 1. So in other words, if I input 0, what do I get out of it? I get a 1. What if I put a different number in? Let's say a 1. What if I input a 1 for x? I get a different output. Let's see what we get this time. 2 times 1 is 2, and 2 plus 1 is 3. So I input a 1. What do I get out? I get out a 3. Let's do one more here. What if I put a 2 in for x? The input is 2. What would I get out of it? A 5. So my x values are the input, my y values are the output. Or we call those the independent and the dependent. Let's turn the page. Over on the next page, there's a couple of blanks that we're going to need to fill in. Up at the top, it says the values of blank. The values of blank. Here's what I need you to fill in for. The values of y depend on the values of x. Top of the next page. The values of y depend on the values of x. In other words, the y value I get is going to depend on what number I plug in for x. Goes on to say that the variable x is called the, we just saw this a second ago, it's called either the input or the dependent independent variable. The x variable is called input, for the independent variable. The set of permissible values for the independent variable is called the domain. We saw that word yesterday. Domain. So all this stuff is referring to the x's. The word input refers to the x's. Independent refers to the x's. The word domain refers to the x's. So these three words that I have here all pertain to the x's. Now we're going to take a look at the y's. The variable y is called the blank or blank. Well, the opposite of input was what? Output. So we call this one the output. Or the opposite of independent would be the opposite of independent is the dependent. Dependent. So the y values are called the output or the dependent variables. The set of permissible values for the dependent variable is called the opposite of domain is range. There it is. Range. So the word range, the word output, the word dependent, all of that stuff relates to the y variable. Everything related to the y. So remember I said there were two words that I was going to add today? Those two words are independent and dependent. These are the two new words that we're adding. Remember, independent goes with the x, dependent goes with the y. That's what we're adding today.
So as long as it says independent goes to y, dependent goes to the x.
Yeah, for right now, that's good enough. Now, down at the bottom, you've got a little table that we're going to fill out. Now, we just got through saying that independent was what? The x or the y?
The y.
Independent.
Oh, independent, x.
X, dependent is the
Y.
y. So if we take a look at the first scenario we have, Lake Travis will rise 2 feet if it rains 15 inches. So our independent in this particular case is the amount of rain. I want you to write that down. The amount of rain. The dependent, on the other hand, is what? The rising water. In other words, how much the water rises is going to depend on what? How much it rains. So the rising water depends on the amount of rain. Obviously, if it doesn't rain, is it going to rise any?
No.
No. If it rains 20 inches, is it going to rise?
No.
Oh, yeah. So the amount of rain is called the independent. The rising water is the dependent. Now, as far as the domain and range, remember those are the x and y values as well. But this time we actually want the values, the numbers. So in this case, those numbers were 15 and 2. So the amount of rain we got was 15 inches. That's why I have the 15 there. How much did the water rise? It was raised by 2 feet. So that's where that 2 is coming from. Okay, so the domain and range are the actual numbers, the values. Independent, dependent refers to what those values mean. The next one's a little bit trickier here because we said those could go either way. So number 2 says that Henry has an arm span of 64 inches and a height of 66 inches. So the independent can actually be either one of those. It could be the arm span or the height. Arm span or the height. Which means if either one of those can be the independent, same thing is true for the dependent. I can either have the height or the arm span be the dependent. They're interchangeable. And if you look over here for the domain and range, what were the actual numbers for the arm span and the height? They were 64 and 66. So the domain could be either one of those depending on what we're using for the independent. The range could be either of those numbers depending on what we're using for the dependent. The last one, number 3, we were given a function, y equals 2x plus 1. So right now what I'm looking for is the independent and the dependent. The independent
It's 2.
is the actual x,
Oh.
and dependent is the
Y.
X is independent, y is dependent.
So 2 and 1?
That's right. Well,
Oh,
let's
1,
go.
2.
Let's get your chart right. Domain and range. Now we want the actual values. Now, if you flip to that page that we just did, guys, on the very bottom of the page, when we saw y equals 2x plus 1, the domain, the x's. The first x that I plugged in was a 0. Is that correct?
Yes.
Then the next x value I plugged in was a 1. Then I did a 2. But really, is that the only numbers that I have to plug in for x? No, I can do just about any number. So that's what I'm going to write for my domain. We're going to put R, capital R, and what that capital R means is all real numbers. And when I say all real numbers, basically what I'm saying here is I want all positive numbers, all negative numbers, and any kind of decimals or fractions included with them. So I can put any number in there for x. Which means if I can put any number in for x, then I can get just about any number for the y. So the y is going to be the same thing, all real numbers. And that's going to be the case for this particular function, all real numbers. So again, domain and range are the values of x and y. Independent, dependent are what those values represent. So basically, that's the notes. Now we're going to take a look at a few examples here, and then you're going to be on your own in a minute. Make sure you follow along. Practice problems. Next page, the first one. Number 1 says that Sue Ann received a statement from her bank listing the balance in her money market account for the past 4 years. What they're asking us for is, what is the independent quantity? So what I want you to do is circle the word independent, because that's the important word here for us. Independent. So, that's what I'm looking for. What is the independent? I'm going to write that down here.
So the x?
So, you're right. Independent is the x. But I want to know, what do these x's stand for? What do they represent?
The time.
Look right here. It says it's representing the
Time.
time. That's what our independent is. It's the amount of time. Now, this question could have also asked you, what is the dependent? What if they had asked us for the dependent, the y values? What do the y values represent? They represent the balance. So independent on this one is the time. Dependent is the balance. There's your person. Look at the next one, a little bit trickier here. The next one. Garrett is in charge of making 120 corsages for homecoming. He decides to ask some of his classmates for help. The number of corsages each person can make can be represented by the function f of h, which is equal to 120 all over h plus 1, where h is going to be the number of classmates that help Garrett make the corsage. We want to know which is the dependent quantity. So let's circle that keyword here, dependent. We want to know what's the dependent. Well, first of all, dependent, is that the x or the y?
The y.
The y. Now, they didn't actually give you a y. What they gave you instead was this funny looking thing here called function notation. So what I want to know is, what does that f of h represent? What does that tell us? Well, if you read the sentence, it tells us exactly what it is. It says it's the number of corsages. So we're going to write that down for the dependent. Number of.
So whenever it has that, it shows you the number of corsages, just write it.
And yeah, usually it's going to tell you right in the statement. Now, they could have also asked you for the independent. So I'm going to go ahead and write that one down because you're going to need to know what it is. Had they asked me for the independence, that would have been the x. Or in our case, instead of x, they used the letter h. Did they tell us what the h stands for? Yep, it says right here, H is the number of classmates. So number of classmates. So dependent is the number of massages. Independent is the number of classmates. So how many massages we can make is going to depend on the number of classmates. Obviously, if we have more people helping us, the more of these we can make. Makes sense, right? More of this, the more of this. Let's keep going here. Number 3, the TN tennis team played a total of 162 matches last season. The number of matches the team lost, notice here that's an L. Why are they using L? Because that's going to represent loss. And the number of matches the team won, notice we're going to use W for won, are represented by the formula below. What quantity does the dependent variable represent? So circle the word dependent. That's important. Dependent. Now, since I'm looking for dependent, is dependent the X or the Y?
The Y.
The Y. Or in our case, they didn't use a Y. What they usually said was the letter L. So did they tell us what the L stood for?
Yes.
What was it?
The number that you lost.
The number of losses. The number of matches that were lost. And of course the independence. The independent is just the opposite. Instead of the Y value, it's the X value, or in our case, it's the W. And what does that W stand for? The number of wins. Number of wins. All right, I'm going to do one more here. I don't have it on my board here, but I want you to look at number 4 here real quick. Number 4 says, Pat hikes at an average rate of 4 miles per hour. The number of miles, we're going to use the letter N for miles, she hikes is viewed as a function of the number of hours she hikes. And we're going to use H for hour. The question is, what is the independent variable? Independent.
Number of miles.
So we got to decide, is independent the number of miles or is it the number of hours? In this case, it's going to be the number of
Hours.
hours. So I want you to write this down for me. Independent is the number of hours. The dependent is the number of miles. How many miles she hikes is going to depend on how many hours she's out there. All right, so this is going to wrap up our notes. Now what I'm going to do is give you something to try on your own here.